Hi, everyone. Welcome to the 8th CS Education Zoo. I'm Will Bird, and I'm going to hand it off to our co-host, Steve Wolfman, who will introduce this week's guest.
Hi, everyone. Welcome to the zoo. This week on the zoo, we're very excited to have Philip Guo. Philip is an assistant professor of computer science at the University of Rochester. He said that he's somewhat new to classroom teaching himself, but the amount of thought and writing he's put into about education is just absolutely astounding. He created the online Python Tutor, which is a great interface for understanding and visualizing Python programs, published his own PhD experience in the PhD grind, and he's written extensively about mentoring, teaching, and diversity, and many, many other topics. He is also coincidentally a Hacker School resident from last year, and that makes him our 4th guest with ties to Hacker School, along with co-host Will Bird, who also has ties to Hacker School. So we're becoming something of a Hacker School themed show. So with no further ado, Philip, do you want to say a few words to the audience?
Sure. Well, thank you again, Steve and Will, for having me here. This is super exciting. So I actually saw this from your 2 previous interviews with Professor Mark Gosdile and Professor Forbes. 2 of those are, they're 2 very admired figures in the CS education world. And when I watched their interviews, I was just gonna watch like a minute or 2 just skimming through it, but I actually ended up like watching most of it because it was really engaging. And I loved how, as professors, we give these very formal interviews that are just like, either job talks or conference things or very technical research talks. And it was awesome to see these very senior, well-respected figures in the research and education world just be able to talk really candidly with both of you about a lot of really deep topics in an informal way. So then I reached out to both of you and said I would love to get involved in this however I can, and you all made it happen. So here I am. So I'm ready for anything. We'll see what happens.
That's awesome. Well, given your enthusiasm, maybe we could also call on you as being a guest co-host if one of us was traveling or something like that. Would you be interested in that? So,
yeah. Well, as all things, time is the main constraint.
Yeah, sure. As always.
As with all things, everything modulo time. But yeah,
everything modulo time. Exactly.
Okay, so I wanted to start in just before we started the screencast today. The broadcast today. We were talking about the screencasts that you've been doing, and it tied into something of a theme that we've had, particularly in Mark Gosdile's zoo, with live coding. So I was wondering if you could talk a little bit about how you're mixing live coding with screencasts and where you see that heading in education.
Yeah, that's a great question. So I'll give a brief description of how I do live coding in the classroom. So I currently am teaching 2 classes. I'm teaching an undergraduate class on web programming, which is mostly actually focused on end-to-end web systems. So a little bit of front-end, but mostly back-end stuff. And I teach a graduate class on kind of dynamic programming languages and using Python as a case study. So in both of those classes, a lot of my lecture is writing code either in a terminal or in a text editor, and then I stop occasionally. And because I have a Microsoft tablet computer, I can actually stop and turn on ink mode and write over my code. I can draw diagrams, I can draw flowcharts. I can also, for web programming, for example, the edit run cycle is you write some code, switch to your browser, reload it, and maybe open that browser console to inspect elements or to debug. And the nice thing about having a mixed modality of pen and typing is that I can type and show real code, but then I can also stop and step back and do the writing as though I was on a blackboard. And I think that's really, really cool for something like computer science where you really do need to see code. And Khan Academy's done really well with pure ink, right, which is a black background and just pure drawings. But I think for computer science, I imagine pure drawings would be really hard because you have to tediously write out all the code. So that's the extent of my I've been really happy with this live setup where I'm coding and also drawing with ink, and I think that's pretty unique, and I would encourage more educators to do that if they have tablet-like computers.
So just to clarify, you're actually drawing in the context of the ink, so you can circle a line of code and say, oh, here's what's going on this line.
Exactly, yeah. So everything is, basically the drawing app is just an overlay on top of the desktop, so you see all the real things. So the only downside of that is you can't scroll, right? As soon as you scroll, all your drawings get off, so you have to stop it at a point and then move. And the other thing is, this is for all screencasts or coding, is just you have to have your fonts be really big. That's a generic tip. Make your fonts larger than you would ever expect.
Okay. So then another item that's come up recently, when we were talking to the team from Hacker School, they were talking about fear as an important element of learning, well, an important element that impedes learning, and ways to remove it. And I'd read your blog post on removing fear in education, and I was really curious about it. So I was hoping you could sort of answer two questions. One is, since a lot of our viewers probably haven't read the post, just to kind of summarize your thoughts. And the other was, I sort of feel like a lot of students have a fear, in some sense, of education, of learning. And I'm wondering if you see that too, and if you do, if you have thoughts about removing that fear.
Great. So the first one is a recap of the blog post, and the second one is a this kind of larger picture of fear of education in general. So the second one might be hard to answer because that's a pretty big metaphysical existential question. The first one is really funny too. On another meta note, it's funny because I've written so many blog posts over the years that I actually forget a lot of what I write. So one of the funny things, people ask me, oh, how come you blog so much? I mean, Matt might also, he would be a great person to interview, does this too, because one of the big things with academics and blogging is that it's a way of externalizing your memory, right? Like if you gave a good lecture, go write about it. If you had an interesting read on a paper, write about it. And a big purpose of my own blogging and writing online is so that I can actually forget about what I said, so that it's externalized. So when students ask me 5 years later, what are your thoughts on learning Python? And I'm like, oh, look at this blog post, rather than rehashing it. So I should actually, let me actually pull it up right now. I'm a bit embarrassed, but I remember writing that article. That was when I was actually working at edX. So I remember, it's funny because I remember the behind the scenes a lot more than the articles themselves, because the articles usually come to me as I'm walking to work or something, and then I just write something out. What is this? Removes fear. Yeah, so I remember this is June 30th, 2013. So that was when I was working at edX as a visiting researcher in the last summer. And it was a really short post, and it's about, right, okay, good, so I have that pulled up. Yeah, so the summary of the post is, I mean, you can all link to it, is that, I kind of characterize every single computer science class in a curriculum. You can view it as though it's removing fear of something related to computing. So an example is, let me see. An example is, let me see. Am I still in the link? Ah, here we go. Sorry, I have too many windows open. One example, so like an operating systems class. So that's kind of by programming in low-level C. In an operating systems class, dealing with seg faults and everything, it's not because you're really expected to build an operating system after you graduate. Pretty much nobody builds an operating system unless they, work on Linux full time. But it's just removing the fear of programming in low-level C and getting all these weird errors and debugging. So I kind of try to cast many CS classes in that way, and I think that a big purpose of education, especially kind of formal education, isn't necessarily, there's this trade-off, right, of kind of vocational training versus liberal arts or humanistic training. And in computer science, we hit this a lot because on one hand, people are saying, oh, you should major in CS because you get all these high-paying software engineering and jobs and such. And then they expect the curriculum to be very vocationally based. How do you learn Ruby on Rails? How do you learn Ajax? How do you learn X? But on the other hand, from a CS and an academic perspective, we want to teach them general principles because we know that the web framework of choice today will not be the web framework of choice in 5 years and so forth. But then you can't just teach all theory either, because then the students will revolt and say, oh, this is all useless. So one way I'm thinking about framing these CS classes is, let's say you never have to write a line of kernel code in your life. Why is this class still useful? And it's useful because it's helping you get over this fear of debugging and those sorts of things.
Mm-hmm. Okay, so then thinking about the students as they come into a course, or as they come into a mentor-mentee relationship with, say, a research supervisor, I also feel like, again, there's a lot of fear that students suffer in that situation. Fear that they're going to do poorly in the course, fear of a supervisor when they're in a mentor-mentee relationship. Have you thought about maybe ways that we can remove those fears? Putting you totally on the spot. Sorry.
This is a big question. I mean, this is one of the big. I think Mark linked to one of the blog posts or out of research also done at Georgia Tech by some of his colleagues talking about, it was in CACM, it was talking about how the motivational aspects that hinder people to learn computer science, especially women and underrepresented minorities, could be greater than the technical aspects. I mean, obviously, we've understood through decades of research on the technical barriers to learning programming, understanding aliasing and memory models and recursion and all these features. But fundamentally, even let's say even if all those things we solve all those problems, I think there's a bigger problem of the motivational gap, because programming is about or computer science and programming in particular is about getting things wrong all the time, and it's about seeing your classmates have 10 more years of programming experience than you do, especially if you didn't come from a group that traditionally had a lot of exposure. So those are really hard questions. And one way I've thought about that is that in my classes, I try to, as much as possible, to eliminate the need to have prior background. Of course, that's not always possible because you have prerequisites and such. But what are some? I think I had some notes about a blog post for this. So one particular point is what's a particular? Oh, one particular point is maybe not to say, oh, this is like really hardcore stuff. Like, whoa, you got to be a real ninja to get this, because then if people don't get it, they think that they're not meant for this, and they get really discouraged, and they have this stereotype thread and such. So trying to be tone neutral is good. And also the other thing Mark mentioned in his post, in his interview, which I thought was great, was about how you don't want to get too opinionated about different technologies or different things. So I'll give you a very concrete example. So my web programming class, you can imagine there's 5 million ways to do everything, right? And their projects are purposely open-ended. So I just you have to make a CRUD web application that does AJAX. So you have to be able to create data, read data, update, delete, do some AJAXing, very basic web app stuff. But for the project, I leave it very open-ended. You can use whatever you want as long as you get the job done. And that has the side effect of giving students a lot of freedom, but that also makes them really overwhelmed, because which library should I choose? Which language should I choose? And that's part of the adventure for them. And I've had students ask me questions that if you posted this on Hacker News or Reddit, you would get flamed 1,000 times. Like, well, you should never use this language in this library for web programming. That's a moronic idea. But when I get these questions live, both in lecture and in lab and personally, I have to really keep a poker face, right? That even if I know, wow, this is probably not going to work really well, I have to be like, all right, if you know this language well, we could try to stick with it. Or I say, this language probably doesn't have a lot of libraries or documentation for web programming. So if you do this, you might run into a lot of hurdles. And other languages have a lot of good documentation about web programming, so you might have an easier time. So casting things more as neutral choices rather than like, oh my God, you shouldn't ever do that because it's terrible. Because then if that's the only language they know, then they feel kind of bad about it. So I think it's really hard. And CS is really hard. The sphere is really hard because this is a well-known thing to both of you and people in the audience, is that it's one of the things where students can have a very diverse amount of prior background because there's this hobbyist nature and it's easy to get started. You have kids who are getting started at age 8 doing programming, and then you have other kids or students who come in at age 18 or 21 who've never programmed. Whereas if you all major in, I think if you're majoring in Russian history or something, right? Like classic Russian history, chances are you probably didn't grow up doing research in Russian history. You might have read a lot of novels, and that's cool, but you just didn't have that extremely deep experience gap. Whereas CS, you really do have that, and that's one of the big challenges in CS education, I think. And I don't claim to have any answers to that, but I do claim to know that this is a giant problem.
Okay, Will, can I monopolize another question, or do you want to?
Sure. I just had a quick follow up to that point. Actually, was so another aspect of it is that sometimes the students who have the most programming experience actually have the most trouble when they're coming in, right? Because so speaking of having a mindset of a particular way to do it, they may have already been programming in C++, and you're going to teach them Scheme and how this is a toy language or whatever, or they're not used to recursion, or it could be vice versa or whatever, right? So they've already have some model of what programming is about, and if you change that, then that can be very uncomfortable. And I was just curious what your experiences have been with that, and if you have any ideas or techniques to try to maybe that's the opposite of fear in some ways. It's
it's overconfidence.
It's the overconfidence, right? Or like, I know the way to do it, when of course there isn't one way to do it. There are many. And
this is a great point. This is the other end of the spectrum, and I sort of want to write about this after my class is done. Maybe if I get around to it. It's weird to write about during the time because I have like students following me on Twitter and stuff. But one of the things I've mentioned offhand to friends is that I remember when the class was starting, my web programming class is much bigger. It's about 60 students. So it's not like giant big, but it's it's a sizable. So out of 60 students, what I found very anecdotally is that the only students who came up to me at the beginning of class who sort of expressed that like, oh, I already have like hacked on code before, I've built web apps before, is this class gonna be too easy for me, whatever. And these are all pretty much white and Asian males, right? And the only students who came up to me before class who were very uncertain about whether they do well in the class were usually minorities or females. And this is not unexpected. And the funny thing is that some of those students who came in with a lot of prior background, they're very confident and such, like I don't think they're doing they're not doing terribly, but they're not acing everything, right? And I think a big part of it isn't, as Will mentioned, necessarily different language or paradigms. It's just the fact that self-teaching programming, a lot of times you just develop bad, sloppy habits. So it's not really a matter of I learn in C++ style versus Scheme style versus ML style. It's a matter of I learn badly by myself, and now I have to try to learn it better. And if I already learned it badly by myself and it kind of half works, I may not be as motivated to try to learn it better. Whereas the students who might have not come in with as much background, they might be more conscientious about learning it better and such. But again, these are very gross overgeneralizations. That it all, if you plot out these things, it would be a ton of noise everywhere. It's not like there's a clear-cut line you can split.
All right, sorry, go ahead, Steve. I know you had a question lined up.
I did. So part of the reason that I was really excited about your offer to come on the show is because going back to the fear theme. This will be the fear episode. It's after Halloween.
Right.
Is a fear for me, and it's a sort of an imposter syndrome fear that I'm just can't possibly be a good research supervisor. I came into a teaching-oriented faculty position for a reason, because I feel good about teaching. I don't feel so confident about research, but I end up advising a lot of undergraduate researchers and occasionally graduate researchers. And I feel very out of my depth and unsure about a lot of things. And you've written quite a bit about mentoring, so I kind of wanted to ask you one specific thing,
Sure.
Which is with my students, what do I do when I'm advising them to feel confident that I'm really helping them make progress on their, whatever you want to call it, their learning, their research, their career, their sort of high-level trajectory?
Yes, these are hard-hitting questions. So I guess my preface for this is that I don't claim to be an expert in research advising by any means. I'm just starting out. I think part of what makes it interesting in my own role, because you're more senior and you've done this for a lot longer, is that in my own role I think it's interesting because I'm almost sort of what's called a near peer, right? That I've done the same thing they have, only 5 years ahead or 6 years ahead or so. So for me, in terms of research advising, it's more like I'm a more senior member of the same team rather than I'm a mentor talking down on, or giving commands from above. And that's obviously a lot harder when you get more senior and you have more authority and seniority and more students and such. But it's a hard question. I think the one point that I would think about is to figure out, I guess maybe to decouple or to not really decouple, to put together two things, right? One is coming to you for a research project. There's kind of two goals. There is getting something done, some progress in terms of a deliverable, which is for grad students and maybe in some undergrads is writing a research paper, a deliverable, and then the second one is what are you learning or getting enriched as a person or as a researcher doing that. And those two goals, I think, in the ideal world, they come together, right? But in a straw person example, it might not, right? So one example, one corner is you're just having them do a bunch of stuff that they don't learn anything from, and you just kind of they're just doing a bunch of stuff for making the project move forward. And the other one is it's a pure learning relationship. In a way, Hacker School sort of that end of, the goal of Hacker School for you is not to write a paper or make a company, is to just learn. So people are there to help you learn and learn and learn. So, but in a research lab, you can't do one or the other, because if you just spend all your time with students just helping them learn and improve as a person, they might feel really good, you might feel good, but then ultimately no progress that's made toward your research or end goals. And the other end is if it's just about cracking the whip all the time and working, they don't feel fulfilled because they're just doing a bunch of grunt work. And the hitting the middle, I think, is the key step in research advising. So one thing I've seen that has kind of worked for me with a sample size of one student and one project so far is figuring out what new thing they want to learn from this project and then catering the project to learning. So I'll give you an example. So one of my first undergrads, who was awesome. He contacted me over the summer, and he came in. I had a project that had to do with digital textbooks, doing a large-scale data analysis project, and I said, we have some data here that I got from some colleagues. It's sort of cleaned up, and if you like to take a crack at analyzing it, we could see if we can find empirical results and maybe write a paper about it. And throughout that course of these last 2 months working on it, he's learned to get pretty good with PostgreSQL. Like, he's learned to write SQL pretty well. Like, he writes more SQL than I do because this data set just happens to be in a Postgres database, and he just writes some crazy SQL to grab stuff out and do, kind of data analytics stuff. And he grabs that and he puts it into MATLAB to do stuff. So then I said, that's awesome. So for his next project, what he wants to learn is something like R, which is like, doing more data visualization and stuff in R. And he's taking a class. He's planning to take a applied stats class which uses R, so we're going to try to cater his next semester's project to do more kind of visualization and data now. I think that kind of keeps students motivated, where they're realizing that they are not only contributing towards some goal, which is important, which is publishing a paper or such, but they're actually learning in the process. So maybe it's in terms of framing every project with a student of what's the deliverable we want and what new skill or what skill are you trying to gain or improve from that? And that's pretty cool, because if you have a PhD student doing 3 projects and learning 3 new skill sets, they have 3 papers and 3 new things they can do that they couldn't do before. I think that's a win-win for everybody.
Right, I like that. Definitely, that is something I can think about with my current student, who's probably going to watch. Hi, and my subsequent students as well. Okay, so let's see. I had written a bunch of follow-ups to that one. I have a bunch of other questions.
Like a bunch of branching stuff, yeah.
Yeah, you know what? I'm gonna. I didn't. I was listening too carefully, and I didn't get a chance to prep my question. So I'm gonna ask one of my stock questions.
Oh
and then
no, stock questions. Okay, all right.
Stock question. I forgot to ask this one. I've asked it every other episode.
Okay.
So I've got 2 I ask every episode, except one. So describe a teacher you've had that you admired, and what you admired about that teacher.
Wow, that is really stock. That's the most stock of stock questions. Wow, this is like it's like being interviewed for a college scholarship when I'm in high school or something. Let's see. I think I would say the most memorable experience had been my 8th grade English teacher. Again, I never had one of these. Well, as a preface to all this, I never had a one of these moments out of the movies where it's like, oh, I hated school and everything, and then one teacher inspired me to go play basketball or whatever, right? I was always, pretty good at school, and I went to public schools, and teachers were pretty good, but it wasn't like, wow, this is amazing, we're gonna make a movie about it. But my 8th grade English teacher, that was memorable in that I actually had a lot of trouble writing growing up. English is actually not my first language. I grew up in China for quite a while, and I learned English when I was around 6, so enough so I didn't have an accent. But throughout elementary school and middle school, I very much feared writing, and also my reading comprehension in English was not very good. I remember, especially fiction, especially narratives and fiction. Like I remember reading in class, like we had to read all these novels and stuff, and I would read it and I wouldn't get what was going on. Then we'd take a test on what just happened to this character, what were they feeling? I had no clue whatsoever. So I remember in 8th grade I got pretty bad grades in some of my essays. I got C's and D's in some of my essays, but my teacher actually gave me very detailed feedback and let me improve on that. And it wasn't one of these life-changing or altering moments, but it was definitely influential. And throughout, I guess, eighth grade was last year of middle school, and then throughout high school, I had 4 years of honors English, and those were always the hardest classes for me. But I always kind of pushed myself to stay in the honors classes, and that really gave me that. We talked about the fear thing. That really got me over a lot of the fear of reading and writing critically in school. So I felt like if that just went to college, I felt like the most influential courses for me and teachers were the English ones, actually, because that was my weakest subject in school, and that those obviously pay lifelong dividends. The writing and critical thinking skills pay lifelong dividends wherever you are. So I would say a collection of English teachers in high school.
That's a really interesting answer. It's neat to hear about something that had really hindered you for a long time, and yet something that's a strength. Yeah. All right. So, Will, you or me?
All right. So, since we've had a Hacker School theme going on, let me ask you about Hacker School. So you were a Hacker School resident at least once. I don't know how many times you've done it.
Once, yeah.
Okay. And Hacker School is interesting because it's very project-based, and like you said, students are there to learn on their own. It's very interactive, lots of pair programming, things like that. And I thought it was interesting to see people learning programming that very intensive project-based style. And I'm just curious, after that experience, has that experience made you think any, or do you have any ideas of how some of the things you saw at Hacker School could be integrated into your traditional teaching at a university?
Yeah, that's a great question. I wrote a blog post. I read about everything about my experiences there, and the ending was really about. Well, I'm sure you have a link to that somewhere. The ending was all about what can we think about the Hacker School experience taken to traditional education. I didn't write a lot about it, but it's I think what I've done in my web programming class has been influenced a lot by that. So in my web programming class, I have basically two components. There's you go to lecture and you listen to me talk and do some activities, and we give you exams on paper on these concepts. So the exams are all concept-based, like, what does this code do? If we, what is the difference between X and Y? Or Alice says that X should be the case, and Bob says Y should be the case. Who is actually right, and why are the other person wrong? So very conceptually based. And then the other half of the class is all as a group project that's very free form, and you just go for it. And we have milestones along the way. Like the first milestone is you better know how to create a database and insert something in a database. Second milestone is have a login system or whatever. And I felt like that combination was good because on one end there's the let's just Hacker School it, and if I model my class after all Hacker School, it's just like, all right, 60 students, group projects, day one, go for it. The other model is the rote mathematics model of every day we're going to go in and learn some concepts and have you write code on paper and check right around, but you never code. So obviously the balance is somewhere in the middle. I think there's the advantage of the Hacker School model is great. One of the issues is that it really does require a very selective audience. I wrote another blog post about this where I helped this person who was in his 40s do programming very intensely for about a year, and I did tutoring over Skype, and that project-based thing worked really well there, and I saw the same in Hacker School. But one of those things that people just have a very high intrinsic motivation, right? They're obviously there to learn one thing, and then in that way, all you have to do is just be a mentor and guide them along the way. Just, they're stuck on something, you help them debug or you help them point to documentation. But I think for most students taking most classes, they're not going to be that enthused about it. Not just because they're not enthused in general, but because they're taking 4 or 5 classes, and unless that class happens to be awesome for them. I remember taking 30-something classes in college. Most of them I would not have had the Hacker School level of enthusiasm for, right? Like Economics 101. I'm not going to do awesome economics projects and run simulations. I just want to take a test. So I think the mix of project-based and it's a really hard thing. And education is one of these things broadly. I've been reading a lot about in the literature, both popular literature and it's one of these things that education is sort of like psychology or the social sciences, where it's one of the things where like everybody thinks they're an armchair expert, right? And whereas nobody thinks they're an armchair expert on string theory. Only if you know string theory do you think you're an expert. But so there's these camps, right? There's one camp of the very kind of a discovery-based learning, constructionist, self-guided, unschooling camp, and there's the other camp of very targeted learning, mentor-focused and such. And people go back and forth about which is better for which settings and stuff. And there's a really interesting paper that Mark linked to that was about a set of researchers refuting a lot of the claims about discovery-based learning and such. And then there's obviously a lot of these discovery-based free-form people who don't like formal instruction for various reasons. And in my very amateur take on it, I think it's just the audience. I think if you have a very self-driven audience with a low student-teacher ratio, you can really do the hacker school thing well. But I think in a large classroom somewhere, it's going to be really hard to manage that. If you don't do that project-based model well, it just evolves into chaos. And I think a lot of students want more structure to it and more structured learning goals, targeted feedback, all the stuff. But again, I'm just armchairing at this point because I don't have actually too much experience with this. But hopefully that helps.
Yeah, thanks. Steve, you had a question?
Yeah. So let's pivot to a piece of software that you created, the online Python tutor, which I've played with some, and I wanted to ask what I fear will sound to the audience like a mean question, but I believe it is not a mean question.
All right.
So here's my preface to say it's why it's not mean. Well, I'll say what I was going to ask. I want to ask, what do people learn from the online Python tutor? And the reason I think it's not mean is because I went and tried it, and after trying it for a while, it asked me what did I learn, and I'd learned something, and so I typed in what I had learned. So I figured you must be getting all of these things. So
yeah.
Maybe you could can you maybe show it to us quick? Can you do a screen share?
Yeah, I can do a screen share. Let's try that. I'm gonna do this and then share my browser. Okay, so that shares this browser window, and then let me switch to this browser. Okay, so you can see me go to pythontutor.com, right?
Excellent. That looks like it's working.
So if you go to pythontutor.com, so this is in general, this is a tool that's freely available for you to visualize the execution of Python programs. So the motivation behind this tool is that visualizing and drawing diagrams of programs is really useful for helping students understand what your computer program is doing, because the internal execution state is often invisible. So here I'm stepping through a program. You can step backwards or forwards, and it has these stack frames here. It has objects, it has pointers, and so forth. So you can actually edit the code as well. So when you edit the code, it brings you to a code editor where you can write code, whatever code you like in Python. You hit the visualize button, and then it brings you to this screen, and then you can just step forward and backwards. So the interface is fairly straightforward, and what this allows you to do is kind of replicate the sorts of drawings you would normally draw in a CS1 in an intro class. So that the design model here was whatever people could do in a Blackboard, we want people in an intro class, we want people to be able to draw on the computer automatically. So there's several main use cases. So one use case is for instructors creating content. So if an instructor wants to create a textbook or notes, they can just embed these drawings in it because it's on the web. Or they want to do a live coding, like we talked about live coding earlier. They can actually live code on here, and normally when you live code, you can only see the final output. But now when they live code, they can hit visualize, and they can see all the internal state. The last use case is for students for self-understanding. So if you want to understand what's going on with your code, you can paste it in, or you can try out variant and hit visualize and see what happens. And this is a really powerful use case, a learner-centered use case, because oftentimes the learners don't know what the right drawing is because they don't actually have a correct mental model. So seeing that really clarifies things. So to get back to your question of what did you just learn, I have this comment box up here that I've just been collecting data for. I haven't actually done a real analysis of it. Data has been trickling in. Some of the ones I've seen are kind of just function call stack frames, pointer aliasing, recursion. I think those are the three big ones. Just this idea that when you call a function, you have these stack frames, and they have local variables inside, and you're passing the parameters around, and these objects are actually alias. So, for example, I can actually turn on my pen, see what happens here. For example, this. Whoa, what just happened? So these two are actually alias to the same thing. Can you see that red ink? So these two are actually alias to the same thing here.
So I'm not seeing the ink, but
No, that's
I
okay.
briefly saw the arrows light up when you had your mouse over them.
Yeah, so I think it's fine. So I'm going to stop the screen share. Let's see. Um, yeah, so that's the general overview of the tool, and the main learning is just about, from what I've seen informally, just on the online surveys, and also talking to students and instructors who use it, is just yeah, basically just learning the basics about the memory model and execution flow, which is a big topic, obviously.
All right. Well, now I'm jealous because I want that tool for Scheme.
Right.
Doing, there's the classic, box and pointer
Mm-hmm.
Scheme con stuff, right? And a lot of students have trouble with that. So, okay, that's basically what I want, is exactly what you did. But I want it for Scheme.
Yeah. Well,
So,
that's one of the classic feature requests is, how do you do this for another language? And people have actually built backends for JavaScript, Java. So the most robust one besides the Python one is in Java, which is from David Pritchard. He's at Princeton. He's currently a lecturer at he teaches the giant intro Java class at Princeton, and he's taken over the backend for Java, and the front end is exactly the same pretty much, because the front end is all web-based JavaScript. The back end is what plugs into your programming language debugger to do the stepping and tracing and kind of crawling of the heap and stuff. So he made one for Java that he uses in his class all the time. So I'm assuming that's pretty robust. People have made ones for other languages. It's funny you mentioned Scheme, because one of the what's his name? It's one of the Johns who is involved in Racket. He's a Cal Poly. You probably know.
Oh yeah, John Clements.
That's right, John Clements. So he and his son, he made a very early prototype of a tracer using in Racket, and he was going to have some students do it and such. But yeah.
Okay, well, I'll have to ask John about it then.
Yeah. So other languages are definitely on the table.
Great. That's really cool. I like that a lot, actually.
Cool.
All
right, Steve. Do you have a follow-up for that?
Well, I don't have a follow-up right away on the Python tutor. I mean, I can say as I'm watching it that it's I'm definitely going to look at the Java version, because an issue that we have right now is we have a really interesting pure functional, almost entirely pure functional intro course.
Oh, cool.
Which really focuses students on software engineering, software design. But because it's essentially pure functional, students never get a memory model. You don't really need a memory model in a pure functional language. And so when they move on to imperative languages, they're trying to understand the language, but they never draw diagrams, because what would you need diagrams? You just do algebraic reductions and you've got your code.
I mean, you can still visualize pure functional. You just do Racket has that stepper. Docker Rack has that stepper where it reduces and such. But yeah, you use a substitution model. Yeah.
But it's a very different model, right? And it's not really a model of memory.
Right.
So I think we need tools like that. But that's not really a follow-up question. That's more fanboy stuff. So.
Cool.
Will, if you didn't want to follow up on that one in particular, I've got another one I can dive in with.
Well, I don't really have a follow-up, but I certainly have questions I can ask. But anyway, if you get a question,
go for it. I've asked a bunch. Go for it.
All right. Yeah, you have asked a bunch. Enough of that. Okay, so I guess I'm just curious, because you've thought so much about education, you've written so much about it. What are the things that you've learned, or philosophically, kind of what it, can you describe sort of your viewpoint now of how you want your classes to run, what the environment in the class should feel like? I mean, like if I went into your class now versus say when you first began teaching, right?
Mm-hmm.
What changes have you made, or what things do you think you've learned about? What do you think is important? What do you think? There are always trade-offs, right? Like what things do you optimize for?
Well, it's a hard question.
Not worry about as much.
I'll ask you super hard questions. Well, the first point here is that I don't actually have a ton of classroom teaching experience, right? So because I just started here. I mean, this first semester I'm doing 2 courses. The first time I'm my own 2 courses. When I was a postdoc last year, I co-taught a big class, a big HCI class there. That was really big. That was like almost 300 students. So I co-taught with several other professors. And then in grad school, I did the usual TAing and such. So I haven't had a ton of on-the-ground experience with this, but I've read a lot about it. I'm obviously a big I study this a lot. So I think the higher order bit that comes to mind is this providing an inclusive environment. It's very much in that hacker school ethos. So it's that what I really want is, as a baseline, I want people as much as possible to not have that comfort or that fear that they don't belong, or that they're not meant for this, or they don't have the prior experience. I want that to be as that kind of and hindrance to be as low as possible, because I think that I feel like, especially in a computer science or programming thing, that effect just intuitively might drown out all the other things. Maybe, I don't know. Maybe that signal of fear and not feeling like you're part of a majority group, or you're not part of the in crowd or whatever, might just be such a big multiplier that impedes your learning, that no matter how good I do pedagogically, or how many quizzes we have, or how much feedback we give you, or if I spend 120 hours in the class, if a student just has that fear, they just can't absorb it. So I think that that's the baseline I start with, and I want to write about this a bit. But so several of the points I had were, one, I think I mentioned earlier, of kind of not disparaging different languages or paradigms. Second one is not saying something is super hardcore and ninja-like or whatever, because that just creates a stereotype threat, especially amongst minority groups, of like, oh my god, this is supposed to be really hard, I'm going to choke up on this and not do super well. Whereas if maybe you're in the majority group, you don't care about as much. I mean, they see this with classic standardized testing results with minorities, right? If you make them aware of their minority status and that they don't belong, they do worse and such. So removing the stereotype threat, not having these strong kind of geeky opinions on, oh wow, you should definitely use Perl 6 versus whatever, or Scala, or whatever, right? I don't know how you would ever compare those, but and the third one was, what was it? I had a few points on that, but I think I want to write a post about what are really easy things, well, not easy, but what are non-time consuming things you can do to make your environment. Oh, the third one is not gender pronouns. That's a big one. Non-gender pronouns is a big one. So both in terms of referring to programmers as male implicitly, but also a bigger note with non-gender pronouns is not referring to inanimate objects as male, right? So a lot of times people just say this all the time. It's like, oh, this guy over here, or this guy, we're going to take this guy and go that. So you just have to say it, or this pointer, or this thing. So those things, I think those micro expressions and habits are really important, and I feel like those are good habits to have in general, and that's the big thing I've taken in the classroom this year as my first experience doing it, because I find myself, I have to actually try to catch myself not saying certain things in the classroom that would be extraneous or perhaps discouraging.
And sort of a related question, in addition to making sure you have a very welcoming, inclusive environment, are there any is there any advice or any things that you think that, say, graduate students are just beginning to teach, or things like that? Are there any words of wisdom you could give them, or pointers or hints? If you could tell a new teacher starting out, like one thing, if I'm a new grad student about to teach a computer science course, like is there any advice?
I think the really big thing is this being aware of your own expert blind spot. Right? So the expert blind spot is this idea that as you become more expert at something, you really forget how hard it was for people to learn it the first time. And things that you think are pretty obvious, that a great example is command line stuff, right? You go pop up a terminal and you write blah 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 blah, run. You're like, yeah, let's just do that, just run this. And if there's like 500 things that people don't know, and you're like, oh my god, what just happened? And then you lose people. So, and this, I think the expert blind spot thing happens all the time, especially for graduate students who are by definition specialists in their field. So if you're a graduate student in programming languages and you're TAing or leading a section for the undergrad programming languages or scheme intro class, it's often really easy to forget that. And a related thing with expert blind spot is just to slow down. That's the other thing that I think I noticed when I was watching people teach programming, especially, that it's so information dense that if you just don't slow down or for understanding really often, it's just easy to lose people, and that's that's part of the advantage of self-paced things too, that you can go at your own pace, whereas an instructor has to go at some rapid-fire pace. But yeah, I think just being aware of the fact that you probably know a lot more than the students do, and you just need to kind of empathize with them in that way. That's probably the highest order bit, beyond any kind of pedagogical tricks or best practices or so forth.
Sure. Yeah, that's a very good point. In fact, one of the things I always try to do is whenever I'm teaching I always try to make sure I learn something new that I don't know about at the same time. And that always puts me in the mindset of, wow, that was really hard. You know, that was really tricky. And then afterwards, like, oh, it didn't seem so hard after I did it a little bit, right? But, you know, I think that I do that intentionally to try to just keep put myself in that mindset, right?
That's really good.
Okay, Steve, your turn.
Excellent. Okay, so you just segued perfectly into my next question, Philip. So I was reading your blog post about the cultural schism in this workshop that you did for were they librarians?
This is software carpentry. As part of software carpentry, teaching non-programmers to program. Yeah, so for librarians, yeah.
Yeah, and you were saying how you know you're all in there. The team of you are in there teaching them things, and the tools that you're using just look baroque and archaic to them, right? You're using Emacs, and you're using line interfaces, and it leaves them feeling, what are these people doing? They can't possibly know what they're doing.
Yeah.
And I'm right now I'm teaching a course where I feel just like that. I mean, this is the course where the students have to struggle with Unix, and I keep trying to argue to them, you know, Unix has been here for a long time. It's going to be here for a long time. They're amazingly powerful tools. I know they look like ancient torture devices. So my question is, you've struggled with that thought about how to reconcile, you know, the amazingly powerful things we can do and the sort of, I mean, I don't know what the right word for it is other than ancient-looking tools that we use, and I'm wondering if you have thoughts on how to bring students to these tools. Maybe in this case, not so much remove fear, although there is a lot of fear of the command line, but remove sort of disparagement from the student side.
I think a big part of it is the way that this has worked successfully, in my experience, has been, let's say, computational scientists or you know, maybe even business people. I think scientists are my target audience because they're in academia, is that they need to do something for their research. Like, I need to munch through 1,000 pieces of data that someone else gave me in these little text files that have 5 columns each. I need to put them together and find this thing in this column and paste it into this other file and then run this other tool that someone else gave me because my member wrote this or they gave it to me from someone else. And yes, I could do this manually, and I put this in Excel and I correct it and such, and then I paste it all together, and it takes forever. But if I know how to use these command line tools, write simple scripts to put stuff together, it will like save me hours and hours and hours of time. That's a very compelling use case that people see. It's often harder in a kind of a canned classroom environment, like when we're teaching kind of a CS0 type course or a software carpentry thing for, say, librarians, because the kind of toy examples you give in a classroom setting are small by definition, right? You're like, here's my data set of 20 people's names. It has to fit on one slide. So here's 20 people's names. And now let's write a R script or a bash script to call all these other Unix things to pipe them together and move them around. They're like, why don't I just do that? Copy in Excel and just correct 5 rows, right? It's like, why don't I just do that? And that's a perfectly legitimate thing. I mean, even for me, in simple things, I just do all in Excel because it's easy. So I think it's getting them to see that having a motivating application is the key, and without that, I think it's really hard. So maybe perhaps segueing back to the project-based idea, maybe for those classes, you know, if you're structuring it around data science or whatever, the project is, let's go crawl Wikipedia, 10 gigabytes of Wikipedia text, and I want to extract out all the famous people and then use that to look up their data from another database and create a report. You know, there's no way you can possibly do it manually, so you have to learn these scripting tools. So without a motivating application, it is really hard to justify. Word versus LaTeX is a great example, right? It's like, why would anybody go through all this indirection Word stuff with LaTeX when I can open up Word and type in, and here's my flyer for my kids' bowling party, right? But why am I doing all this LaTeX stuff to do that? And the question, yeah, you probably shouldn't use LaTeX. You can just use Word to do that. But if you're writing a large report with different pieces and you want to typeset it, you want to have different people come together, maybe do that. So I think having a motivating application is key, and it's hard to do in a classroom setting.
So I think we're closing in on the shout out time. So before we got there, I want wanted to ask my other canned question, which I hope
Nice.
doesn't feel too much like the
All
high
right.
school job
Go for
interview
it.
or whatever, which is what's something that you think, other than your blog, what's something you think that every computer scientist should read, or rather than read, it can be a tool they should play with, or that sort of thing.
Wow. Yeah, that's like a that's funny because that's the sort of question that you would imagine people asking at a faculty job interview. Like, if you're going to be a computer science professor, you better have an awesome philosophical answer to what should every computer scientist know. But in fact, nobody asks that at faculty interviews. It's basically like, what paper's written? Can you get a grant for us or whatever, right? Nobody actually asks about these philosophical things. Uh, so the every computer scientist, I think, yeah, a seminal work and such. Ooh, so what should every so I guess maybe to target the question more, do you think this is be somebody who is as like an undergraduate, like after 4 years of college, you better have, it'd be awesome for you to know X, or someone who's a practicing programmer or someone who is just trying to get interested. Do you have any idea about the audience?
I mean, I think our audience is that we're targeted at is mostly people who are CS educators
Oh,
or
okay.
interested in becoming part of CS education. So let's shoot for somebody who's on their way to being a CS educator, and something that should be part of their lexicon or their background.
Okay. So I think that's good. I think a book like Unlocking the Clubhouse. So Unlocking the Clubhouse is a book by Jane Margulis and Alan Fisher, and where they did this big study, empirical study at Carnegie Mellon in the 90s about. They did a detailed interview studies of, I think, 100 or so students, with pretty comprehensive in computer science, and asking about their experiences, retention, feeling like they belong. And the focus of Unlocking the Clubhouse was on gender, specifically on the women versus the men computer science, and that was a very influential book for me when I read it, and that really drove home a lot of the issues about kind of implicit biases and all this stuff. So I would say that book, Unlocking the Clubhouse, would be big. They had a follow-up book called Stuck in the Shallow End, which is about a case study on race and computing, and they did studies in with minority children at in LA county schools. And I haven't read that book, but I've seen her talk about that. So, and I think that they have probably similar themes. So that, I think that just reading works that are actually non-technical about this sort of motivational, cultural, and kind of gender and race-specific aspects of computing is, I think that's probably the highest order bit. Because other than that, everything is so specific, right? Then it becomes sort of like, you must read SICP, you must read How to Design Programs, you must read the Dragon book, or whatever book, you must read X book, or you must read this awesome paper, Turing Award-winning talk by X person that wrote this 30 years ago, and it's probably pretty obscure. But but I think something like Unlocking Clubhouse would be a great starting point, because that's very accessible, and it's like everyone just kind of gets it when you read it. Just like, oh wow, like I never really thought about that, but it's so true that if you imagine your relatives, for example, like imagine you have relatives who have girls and boys who are growing up really young, and imagine you're going over to their house at a family reunion, and you see that the computer's always in the boys' room, or when the girls want to go on the computer, their parents are like, no, go play with dolls or whatever. And there's these messages that are just so inherent, that bubbles up through 10, 20 years into adulthood and such. So yeah, that would be what I recommend.
That's great. That's really interesting. And I also wrote down the list of 3 books you rattled off as things that you wouldn't say. So I've got those too.
Examples of classic textbooks with very strong opinions behind them.
Excellent. All right, Will, shout out time.
Yeah. Okay. So, Philip, are there any people you would like to thank, or any links? I mean, we'll link to things in the text, obviously, but are there any things you'd like to draw attention to? Resources other than your blog, for example, or anyone else that you'd want to point viewers to, people who you think are doing really interesting work that they should check out? Anything along those lines?
I mean, the cool thing is you've already interviewed several of the people who I would probably recommend. So that, I mean, the interview roster you've already had has been really good.
You can also suggest other people we should interview, right?
Yeah, we can maybe think about that offline. I'm not super good at thinking on the spot, but in terms of people I'd like to thank, I mean, it's just there are so many. It feels like a high school interview or acceptance speech or something. I think uh, what's been really influential. I think that people in I'm just focusing on computer science in particular. I think academics who blog I think are really cool. So I read Matt Knight's blog for a long time. Mark Gosdow has a blog that's pretty active. John Regier at University of Utah also has a pretty active blog. Uh, you know, Crystal Lopez at UC Irvine. So the kind of people who are blogging about computer science stuff, I think, is really interesting. Both, some people's blogs are very technical, some people's blogs are very social about the social aspects. But I feel like, in particular, academics have sort of we're in this great position of being able to blog very openly about a lot of things, and that the general public takes us quote unquote seriously in a way about these things because it doesn't seem like we're a corporate shell for whatever company. Because a lot of times you see these company blogs and they're good content. There are people who actually really want to help, but it's like plastered with company stuff. And there's some kind of blog about something that's I use our product because it's awesome. It's an awesome way to do data munging. Data munging is a big problem. Blah 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 blah. And then it's always a sales pitch at the end. And some of these are actually really informative, but that beyond, that to justify their blogging and their company, there's some kind of a PR or whatever pitch. And I think the awesome thing about being in academia that, which is why I came into this, beyond just the mainstream things people do with research and education and outreach, is the fact that when I blog about stuff or I read about or when other academics who are much more senior than I do that, the public knows that is sort of a public service, that they're not a spokesperson for a company. It's not like their boss told them, oh, you should make our company look good so we can get more users or more revenue. You should blog about this. It's just that is really the kind of I think that's one of the awesomest parts of being academia is being able to do that, and that's historically been true. And I would love to see that continue. I would love to encourage, and one of the things talking about mentoring is I encourage graduate students to write and blog about stuff. And some people have taken me up on that. There's a big barrier. There's that fear aspect of writing publicly and such. But I would love for more students in any capacity. Actually, one of my students in my web programming class, for her honors writing requirement, she needed to do some writing project. And I said, you should do some blogging about my class. And she's actually written a few things that with her permission, after the class is over, I would love to post it. And they're really great because it's from the experience of someone going and learning from the class and talking about different issues. And I would love to see more students like that. So basically anybody who is blogging is my role model at this point.
All right, now I'm shamed. I'll have to start trying to blog again. I do videos because blogging is hard, but
videos are good.
I'll try blogging.
It's the same, idea of sharing information openly.
Sure. Yeah, definitely. Yeah, I agree. More people should share.
Right.
All right. Well, thank you.
Great. Well, thank you for having me. This is really fun.
Thanks for coming on the show. There's a lot of. This is we could talk all day, obviously.
It's been great having you, Philip.
Awesome.
Yeah, it has. So, very nice meeting you finally. Heard a lot about you at Hacker School, and hope we'll meet up soon. Yeah,
I've read about both of your stuff online, and that's why I reached out. Awesome.
All right.
All right. Well, I guess should we go ahead and end the hangout?
Yep. I guess I'll just say we don't have our next CS Zoo scheduled right now. We do have a couple of, I think 3 guests in the works that we're contacting, so we hope to have our next CS Zoo out for everyone soon. And if you have thoughts, please drop us a line. You can post on Twitter, and use Will's and my handles, W.E. Bird, or, goodness, what am I, Will? My Steve Wolfman.
You never know your either.
Or feel free to email me, wolf@cs.ubc.ca, or Will. I'll let you do the contact. And otherwise, we'll see you all next time on the Zoo.
All right. Thanks. Signing out. Bye.